rules. So first of all, my name is Rafael Elio. I'm policy manager at AVERE, and I'm very pleased to see a lot of people here today to this first of a series of webinars dedicated to the grid. This first webinar is entitled Grid Integration of Electric Vehicles, the Challenges and Strategies. So we're looking a bit at more top-line vision of what is the challenges of the grid, especially for the e-mobility sector. So looking at the road transport segment. And so, as I was mentioning, a few housekeeping rules before we start. So the webinar is recorded, and as you can see on your screen, there's a Q&A button. So feel free to ask questions throughout the session. Our panelists will try their best to answer all of those questions, and Patrick Ryszynski, our moderator, will try to pick up some of those questions at the end of the webinar during the discussion. So yeah, those are for the housekeeping rules, and maybe a bit of an intro word from my side. So as we've seen, over the past years, electrification has been, massive, especially in the road transport segment. It has been highlighted no later than 2 days ago that electrification is actually the best option to decarbonize the road transport segment. And this is not a statement by AVERE, this is a statement by the European Court of Auditors. And so what we're seeing is that the road transport segment their emissions keeps on increasing. And so we really need to tackle that. Of course, the last 5 years have been a confirmation of this understanding that we need to tackle this and that we need to move towards zero emission transport. And we've seen an increasing amount of legislation that have been adopted that are aimed at pushing electrification of passenger cars, but also of logistic trucks and buses. We've seen the adoption of the globally most ambitious CO2 standards for light-duty vehicles, which virtually, not just virtually, just will ban the sales of polluting cars in 2035. This month, we've seen an agreement on the heavy-duty vehicle CO2 standards that confirm the willingness to have a mandate of a 90% emission reduction target by 2040. So that's for all heavy-duty vehicles. We've seen the deployment of a supporting framework to ensure the recharging infrastructure is available and user-friendly through both the alternative fuel infrastructure regulation and the energy performance of buildings directive, one tackling the public charging infrastructure segment, the other one looking more at the private multi-unit buildings, making sure that you can recharge your vehicles even if you live in a multi-unit apartment in the city, so that you can have access to pre-cable or simply just a charging point. And we've also seen, an increasing generalization of smart charging through this legislation and the emergence of a regulatory framework for bidirectional charging. All of this rapid movement towards electrification of the road segment, however, still brings some challenges. And one of the big bottlenecks is the grid. We've seen some elements of responses from the European Commission, notably the Electricity Market Design Directive, which includes some provisions on grid tariff, anticipatory grid investments, flexible grid connection, and non-fossil flexibility. But still the challenge remains, as this legislation is a directive, still needs to be implemented in each of the member states, and it does not answer all of the challenges that are ahead for the electrification of the road transport segment. So this session, as I said, and the series is about identifying the challenges ahead and brainstorming with a series of stakeholders what could be the way forward to succeed this transition. Now, I always talk too much, so I don't want to spend too much time talking. So I will be giving the floor to our moderator, Patrick Ryszynski, who is the president of SEVA, the Slovak Electric Vehicle Association, but also our vice president at AVERE. So without further ado, Patrick Ryszynski, please, and thank you for your time and for moderating this session. I look forward to all the elements of discussion that we will be hearing today, and keeping some of those elements and using them with our co-legislators. So thanks a lot and enjoy the webinar.
Rafael, thank you very much for this introduction. Good morning to everybody. Some people are obviously in snowy Northern Europe. Some are in sunny Spain. However, we all face very similar objective. As we see it in AVERE, our ultimate goal is integrating 100% of vehicles into the grid. And we look at short, medium, and long-term issues, and we try to address the solutions. And this webinar is actually focused on introduction of not only view of the industry on these significant challenges, but also potential solutions. As we already mentioned, action plan for grids from the EU, European Commission, which was introduced at the end of November, brought very good proposals addressing many bottlenecks, with addressing rollout of additional charging stations, make it very quick. And we will be looking at the solutions from the industry. We also want to focus on regulatory aspect and bring some best practices from more developed countries where we can actually learn some good examples. And we also want to speak about solution which is focused on more transparency on the available grid capacity to speed up the charging point connection. So I obviously will not speak myself. I will have panelists speaking and talking about these diverse topics. I have Enrique Merono, Global Head of Quality and New Initiatives from Iberdrola from Spain with me. We have Julia Hildermeier, who is Associate EU Program at Regulatory Assistance Project, looking at the obviously regulatory aspects. And we also have Nazi Refa, who is responsible for data analytics at ELAT, the distribution system operator in Netherlands. We will have introductory presentations from each of the panelists who actually will present their view on their respective topics, and then we will come back with our questions. Obviously, you are more than welcome to send your questions to the Q&A, and we will definitely come back to them. Maybe Enrique, you will be the first one who will focus on the electrification of the heavy-duty vehicles and the challenges that this electrification brings to the DSO. Please, the floor is yours.
Thank you very much. A pleasure to be here. Thank you very much for the invitation. What we are trying to share here, let me try to share the screen with you. That's it. Can you see the presentation? Yeah.
Yes, go ahead.
Okay. So why I think that it's important to share with you today, it's what we think is the worst case scenario for the charging infrastructure deployment in probably all the countries of Europe, which is the case of the heavy duty transport. So this is part of a heads up because right now we are starting in the starting point of this. And it's part also to share some of the proposals that we have from Iberdrola about this. So, the context, regulatory context, it's more or less known for everybody. We have two main levers from a European level. The first one applies to countries, which is the alternative fuels infrastructure regulation, and the other one applies to OEMs, which is the CO2 standards. Recently approved the heavy-duty vehicles, as you already know. So these two levers are going to represent challenges for everybody in the sector. So we make some calculations in the Spanish case because we think that Spain it could be a good example because it's the third country in Europe we are talking about truck traffic. So it's something I think significant, at least to show and to share. So, taking into account the revisions of the targets and for the countries regarding charging infrastructure, and what we think that, the CO2 regulation is going to imply to the market, you see on the left-hand side of the table, our estimations that what could be possible or feasible in Spain by 2027 and by 2030. And as you can see, what we are expecting is more or less, 40,000 battery electric trucks, 36,000 battery electric trucks in 2030, which is something really, really small if you compare about the electric vehicle fleet of light duty. And even this small number of trucks expected implies a huge electricity demand by 2027 and 2030. In 2030 is more or less 30% of the total electricity demand, but even bigger accumulated investments in that period of time. It's that bigger because it's related with the ambition of AVERE regarding trucks. I think that for our point of view, it's a good idea because they understand that the charging infrastructure for trucks is needed, before the trucks appears. Because in a lot of cases, in Spain, I think, and in Europe as well, one day a truck have a small short trip, and the other one it's a long haul. So if you want to, not to force, to help the logistic operators to acquire battery electric trucks, what you need is to have at least a minimum coverage for all the country and across Europe in order to, allow these truck operators to operate with battery electric trucks. The interesting thing here is the amount, because it's ahead of the need in a big percentage. So this is going to imply two things. First, that the problems that we are facing today with light-duty vehicles, we are going to face it by, far more big, several orders of magnitude more with battery electric trucks, first. And the other one is that it's going to be very, very challenging for the CPOs in order to have a viable business model. It's something really challenging today with light duty, with trucks, with that requirements is going to be even more challenging. So this is why I was trying to explain that this is probably the worst case scenario for everybody. And it's something we need to address right now. What we think is very important is the change of mindset regarding as a networks company. I'm removing my hat of CPO. I'm putting my hat of networks company, networks business. In this case, what is really important is the mindset, because usually regulators are very afraid about overinvestment, very afraid about because in most countries of Europe the growth of the energy demand in these last years was not very impressive. What we need to understand is that we need the change of mindset, because if we want to electrify a dispersed but a big amount, but a dispersed locations of demand, of new energy demand. I'm thinking about charging stations. I'm thinking about data process centers. There's a lot of different dispersed, newcomers in the electricity sector that we are going we need to bring the grid for them. What we need to address is that the consequences in this situation of underinvestment are asymmetrically much greater than those of overinvestment, because really the growth of the transport sector in the electrification and the potential growth and the potential growth of other sources, heat, etc., are going to compensate very quickly this overinvestment. So we need to change the mindset. This is a message basically for the regulators, because in most countries of Europe, networks is it's a regulated business. So this is something that we need to address. So just this slide just to show you that the challenge for electricity grid. This is a graph from the International Energy Agency of 2022, and shows basically that in the upper side of the graph, you see the green lines. The green color is renewables. It's the amount of investment in renewables, and the orange in the part of the infrastructure is electricity. So basically, it's electricity grids. So basically, we are going to need to invest closely to €1 per €1, €1 for renewables and €1 for electricity grids. So the amount of investments on grid, it's going to be huge, absolutely huge. So this is something that we need to address. But the message here is that it's possible to do that technically, because this is something that happened in Spain from 1997 to 2007. And as you can see, the increase of the demand in that period was 61%. This implies 6% per year. And we did it without any issue. Why? Because we had the correct regulation for the context of that period of time. The increase of demand in that period was related with factories, big buildings, and it was correctly managed for the needs of that period of time. So it's really possible. We can do that. We calculated what it would be imply 100% of electrification of transport in Spain by 2050 is, well, even more than 2050, because in 2050 probably 100% of electric vehicles is going to be, closely to impossible. But 100% of electrification of transport would imply an increase of 130 terawatts per hour per year, which is more or less more than, it's an increase of 50% of the energy consumption of the country, of electricity demand of the country. So what we're trying to explain here is that it's close, is less than that 61% that we face in 10 years. So in 10 years, we face 61% and we did it. In the whole electrification sector is going to imply 50%, so it's less. And we are going to be able to do it. But the thing that we need is a change of the regulation in certain direction that I'm going to explain right now. This is something very quickly, is just to give you an order of magnitude what would imply of investments in trucks and investment in charging infrastructure. As you can see, the order of magnitude is not exactly the same. Trucks is much bigger, and it's obviously there's a difference between the price in this period of time, that the pricing by 2030, because it's going to be cheaper, the trucks, in the following years. But it's just to give you an order of magnitude of what would imply. So we are talking about 1.4 billion euros during this period up to 2030, and 50% of that is going to be grid reinforcement and extension, more or less. So it's a fairly big amount. About permitting, I think everybody knows. I'm not going to extend a lot about that, because everybody knows that the problem that we are facing about red tape, permitting, etc., in most countries of Europe, not only in Spain. But what we want to stress here is that our proposal is related with the idea of the ahead of need grid extension and reinforcement. So we need to allow the DSOs to invest ahead of need, not invest reactively. We know where are the trucks in the country. We know where are the buses in the country. We know where are the ports in the country. There are a strategic infrastructure for all the countries, and we know the location. We can advance. We can do this investment in advance. Obviously, it would be better if it could probably be part of the regulated asset base, because otherwise, logistic operators with logistic hubs, at least in Spain, because we have a very big logistic hubs in the country. If you compare with other countries in Europe, it's because the topology of the country. We have big cities with big population, a lot of gaps with nobody in the middle. So in these cases, it's really challenging for a logistic operator to have a secondary substation ownership and what they need to operate and do the maintenance of this secondary substation. This is something that we don't think that the people are realizing the issues that it's going to imply for these logistic operators. So what we are trying to bring you here is that we think that could be done in a different way, easier for everybody and quicker, probably. Fast track lanes for permitting process, etc. I'm not going to extend a lot, but more or less this is something that probably most of you are aware, because we are more or less in the sector, everybody. So what we are doing in Iberdrola, we have an umbrella of a project with the CO Alliance that implies the Mediterranean corridor and the connection with France and probably with Italy, but we are extending right now these investments for the rest of the peninsula, the Iberian Peninsula as well. We have strategic agreements with logistic operators. We have right now several charging stations for specifically trucks, electric trucks, and we have a joint venture with BP in order to leverage the risk of the big investment that we are going to face. So we are going to do that together. In the case of Spain and Portugal, in the case, for example, in other countries that we have presence like UK or US, probably we are going to use different partners or different methods. But this is just an example of what we think that we need. And just to end, the good news of the electrification of transport is that the energy consumption of the transport is going to decrease by three times. So this is something that for each country, it's something really important in energy independence, etc. No? So from my side, that's all. Thank you very much, and completely over for the Q&A session after that.
Enrique, thank you for this introduction. If I'm looking at the top 10 countries in the EU in terms of the international transport and the million tons of ton kilometers, which means the carriers the mostly used in the EU, you are sitting at number 4, just behind Poland, which is number 1, Netherlands and Germany. And obviously, we always will have a tremendous issue and challenges to turn all these diesel trucks running around Europe into low emission or ideally zero emission vehicles. So thank you for your introduction. And if you can please stop sharing, because I will give the floor to Julia Hildemeyer, who works on the research focus on the integration of electrified transport in a smarter and decarbonized way, and on the power market regulations. She leads electric transportation program at RAP, and I believe she will be focusing on lots of regulatory issues like demand side flexibility and some recommendations from her side. Julia, the floor is yours.
Thank you so much. Can you hear me and can you see my screen? Great. Okay, thank you. Good morning, everyone. Thanks for having me on this webinar series that we're very excited about. To see all this interest from the transport sector in grid integration issues is really the right moment to start this discussion and create more awareness of the solutions that we need to integrate electrification of transport optimally into our grids. So I want to give you a little bit of an introduction into what we think is key to make EV grid integration successful as the demand of electricity of EVs is rising. In fact, as more EVs are being plugged into grids and the demand is rising, and if I talk about EVs, we're actually also including electric trucks, so really thinking vehicles in a large sense here. Many tend to conclude that, well, all we need to do is upgrade the grids and that'll solve our problem. What we'd say is perhaps a bit more nuanced. We would say that as electricity demand from EVs grows, smart or optimized charging needs to happen. And for the remaining demand that cannot be met through optimization of our existing grids, then obviously we need to upgrade the grids accordingly. And it's without any question that especially for bigger capacities needed for example, truck charging, there will be lots of upgrades needed. But it's also true that there's a lot we can already do by better utilizing our existing grids and enable these grids to modernize, to digitalize, to meet the challenges of all those additional demand for distributed energy resources such as EVs as they connect. So in other words, let's optimize the use of EVs and the use of grids actually by using EVs flexibility today and plan for the infrastructure that we need to serve the optimized demand at the same time. Smart or optimized charging is a term that's really used to describe all kinds of optimization of charging, from simple load management on site to more comprehensive mechanisms that aggregate EVs flexibility to match it with system needs and reduce costs and help absorb renewables, for example, as you can see on this graph. And that's really how smart charging can create benefits for all consumers. For consumers individually, because it helps you to save on charging if electricity is cheaper, but also for consumers, for electricity consumers generally, because as we cause less cost in the system, less cost has to be shared through everyone's electricity bills. So here's the big societal benefit that I always stress when I talk about EV grid integration, because the grids are more efficient to use. And to get there, we need smart charging mechanisms that are price-based and that are consumer-focused. So I want to focus on these today. And that's why we define smart charging as charging at times charging EVs automatically at times when cost of electricity is lowest without compromising the user's needs, of course. And it's really the price of electricity and ideally the pricing of using the networks that can send a signal to the consumer when cost is lowest, hence when is the best time to charge. So let's zoom a little bit more into what needs to be in place for smart EV charging and optimal grid use. Users need the car for mobility, obviously. They can also offer it to the grid as a resource when they don't need it. Same applies to different use case. Imagine an electric truck parked at a depot needing to leave fully charged for delivery route in the next morning. So to be able to optimize charging, fleet operators or private EV users, or actually aggregators that manage their charging for them, need to see when it is cheapest to charge. They need to have an incentive from the grid. And that signal should come from what you see on the left side of the graph here. It should combine, in fact, several signals. It should tell us when energy is cheapest. For example, when lots of renewable energy is available on the power markets. But it should also tell us when is a good time to use the grid, when the grid is overloaded or when there's spare capacity, especially on distribution level. For simplicity, I'm leaving out the local energy flows for the moment and really concentrate on our topic today, which is grid use. And this can be done, so this grid signal can come, for example, through time-varying network tariffs that are set by energy regulators for distribution operators. And how can that happen? Or why isn't that happening already everywhere in Europe today? I want to quickly share some results from research we published last year, and actually stay tuned for an update that we're working on this year. Out of about 140 smart EV tariffs and services we found at the time were available for EV consumers in Europe, most of these were using a type of time of use tariff and added a service to help you optimize charging your car following your preferences. And on this graph, we've classified them by input, which means what are these tariffs optimizing against? For example, some were optimizing your charging depending on the renewable energy you could capture at a certain moment. What I want to draw your attention to today is this lowest bar on the very right corner of the graph, because these are the number of tariffs we found that are optimizing against information on what is happening on the grids, on local grid availability. And this is the smallest number. Only 13 out of those 140 are based on signals coming from local grids. In other words, information from grid operators, when is the good time to use the grid and what would be needed to shift charging. And that number should increase if we want to use our grids better today. And for these grid signals to be conveyed, we need the grids to become much more an enabler of optimized charging, of smart charging, rather than a bottleneck. Right now, speaking broadly for most European grids, and we may hear about some exceptions later, and I'm happy to discuss that, but broadly speaking, for most of the European grids, the biggest stumbling block in many grids is a lack of information and transparency. Information and transparency on what's happening at the moment of charging. That means, can the EV use spare capacity, or should charging be shifted if it can? But we're also lacking in many cases information and transparency on the future, which means forecasted demand from EVs, on all those electric trucks that will be on the road soon. How is this demand factored into grid investment, grid development plans? There are some efforts to improve the planning process, but here's where I join my previous speaker. We need to anticipate much more and much better the investments that will be needed for additional demand from EVs. What we're saying is that we would like to see this additional demand optimally used in the power grids. And this actually requires digitalization, much more than it is the case on average in the European grids, and they're very different, so it's really hard to speak for all areas here. But the ability to measure and communicate consumption of EVs, to have a good insight of what's actually happening on the grid, is really a very basic and key condition to be able to offer any type of optimization based on smart charging services. A good indicator for the level of digitalization is smart meter rollout, that of course has advanced across Europe, but is still nowhere near where it needs to be really to make these benefits available to all customers. So wrapping up, the first condition for smart EV grid integration is transparency, digitalization, and progressive planning at grid level. And that actually includes indeed also speeding up connections for charging points. So I'll just recall that. Now, the second condition for successful EV grid integration to happen is a functioning market for smart EV charging tariffs and services. And here's where I'm actually going a bit beyond, strictly speaking, grids and more into the power market condition, but which are actually essential to make EV grid integration work. So a functioning market for smart charging services that consumers can subscribe to. And here are those same services that I showed you on the previous slide, but now they're mapped out on a map of Europe, as you can see. And you can also immediately see that they're not at all equally distributed across Europe. They're mostly concentrated in the Nordics, Northwest, Northeast Europe. And that has to do with several factors. Again, smart meter rollout is one indicator, but also, and of course linked to that, the general availability of time of use pricing for all consumers, for all consumption, not just EVs. And that is really a basic precondition on which aggregators and other service providers can develop a market for interesting smart charging tariffs and help consumers save on charging and optimize it. And this is indicated by the color that you can see on the graph. The darker the blue, the better the basic market conditions. And I just want to use this extension into car market conditions to also stress that, of course, smart charging is not only needed for private charging, but also for public charging. It should be available to all users in all use cases. And in this case, it's not the private user or the fleet operator, it's the CPO, the service provider, that needs to see those dynamic price signals from electricity markets and or from networks, ideally. And so they can design a service that passes these incentives of when it's best to charge to their customers, to the EV driver. And that service needs to be easy to understand, and it needs to give incentives that people can work with. And here are a few examples. I was asked to give some national examples that are recent. So, for example, in Denmark, there's an increasing number of public charging points that are using spot market pricing for their EV charging offers. It's piloted by Eon Drive, run in Copenhagen, where the tariff is very simple. There's a standard tariff, and there's a 50% discount for consumers who charge at beneficial hours. Easy to understand, but designed on spot market prices. In Portugal, with a very specific approach, which is that the mobility service provider actually delivers the energy, also offers dynamic pricing at public charging points. And another example of an aggregator that doesn't, let's say, pass on a variable price to consumers, but a flat price, is Mobility House in Germany. They offer one static rate for charging, But what they actually also do is they give reward points or bonus points to customers to keep their EV plugged or for a longer time, using that flexibility to then bundle and provide demand response services to the grid, which generates rewards that they can then build in their business model. It's a different pricing or tariff for the consumer, but the principle is similar. The more consumers are rewarded to offer flexibility with their EVs, the more benefits they can generate, the better we use the grid, the more benefits for everyone. So with that, I wanted to show with this slide that the second condition for making EV grid integration work is an energy market framework in place with dynamic energy prices that can help smart charging to develop. And both conditions, getting the signals from the grid and from the energy markets, need to be enhanced with a supportive regulatory framework. So let me get to that before I conclude. What policy framework needs to be in place to support EV grid integration? And I'll focus obviously on the energy market here. We've discussed AVERE and supply side policies already, so this is complementary. First off, we're not starting from a blank sheet. The electricity market reforms from 2019 aren't actually fully implemented yet. And that's important because we're still lacking full rollout of smart meters, transparency obligations on DSOs that come with many exceptions and could be applied more fully across all of the 3,000 DSOs that we have in Europe. Grid connections and access to flexibility markets are topics that we're seeing sort of on the table for the last couple of years. I just want to pinpoint to one really a key provision from those 2019 Energy Market Directive, which is the obligation for energy suppliers to offer a dynamic tariff to household consumers. In fact, if I'm a household customer, I can ask for a dynamic tariff. I can ask my supplier for the dynamic tariff, and I need to get an offer. And these type of provisions really drive this let's say general availability of time of use tariffs that I showed on the map earlier, which is the key market condition for smart charging to thrive. But excitingly, we've just reached a political deal on the new electricity market reforms mid-December. And there are some interesting provisions that will also, let's say, promote a successful grid integration in these newer reforms. For example, member states will be asked to set out national flexibility targets. That means targets to integrate non-fossil flexibility into their system. For example, flexibility coming from lots of EVs aggregated and providing grid services. And here's an opportunity really for stakeholders in the e-mobility world. So many of us today on this webinar to engage in the target setting process that we're going to see on national level to ensure that the flexibility of all those EVs is appropriately considered in these assessments. And that means, of course, flexibility from EVs, from smart charging, bidirectional charging, really in the widest sense. And I'm pointing to that because this process, will start at some time, and I think are a really interesting opportunity to increase the value and the awareness of EVs as grid resources. There's also a provision for supporting smart charging or EV aggregation more generally, and that one is interesting because it reduces the threshold for aggregated flexibility to participate in flexibility markets to now 100 kilowatt, which basically means that a smaller number of EVs is sufficient, can be integrated to act as a grid resource or a power market resource and generate rewards through grid services. And that's good news for charging, for smart charging, for bidirectional charging services. It's good news to develop that market of smart charging tariffs that I described earlier. There are also requirements for improved transparency for grid planning. Distribution system operators are encouraged to cooperate with TSOs in publishing information on capacity available for new connections, for example, charging points in their respective areas, and giving sufficient granular visibility to developers of new energy projects. And that is also an opening for service providers and aggregators to get into that market. So again, more requirements for more transparency, definitely going into the right direction. And there's also guidance on tariff design, basically tariffs, price signals becoming more cost reflective, and enabling DSOs to shift towards leaner operations, increase efficiency, integrate renewables, basically using tariffs to design them in a way that helps them to optimally integrate all the distributed energy resources that we're seeing. All of this is encouraging language, but as Rafael pointed out in his introduction, it needs implementation, it needs a close following by e-mobility stakeholders, it needs interpretation, it needs support on national level, and our recommendation is to watch this space closely in the future. I know I'm probably at time, but I just don't want to quit without mentioning the Grid Action Plan as well. The energy market framework I just described is sort of touching the wider energy market framework that I've discussed. Our webinar focuses on grids, and we need to just recognize that the Grid Action Plan issued by the European Commission in November is actually a first in that it concentrates attention to addressing the grids as a bottleneck and hopefully as an enabler in the future. And even if it doesn't suggest clear-cut new legislation, which is always difficult to do at the end of a legislative period, of course, it is a welcome call that really takes all the tools that are at hand, and certainly also gives some homework to the incoming decision makers on how to prepare the grids for e-mobility and other electrification, of course. So again, very helpful language to network planning, improve network planning faster, and let's say more considering electrification needs from sectors such as transport, guidance on anticipatory investments that are crucial to reduce bottlenecks, and guidance to better use, to smarten the grid and better use existing capacities. I'm not going to go through all the points. It's also fair to point out that a missing piece perhaps is in this action plan is a stronger mandate for national regulators, national energy regulators, to prioritize decarbonization projects. But it's also a good opportunity to recall decision makers in 18-month time. That's the period that the Commission has given itself to deliver on this plan. And again, here's an opportunity for the e-mobility stakeholders to get into the discussion and support the need to get our grids up to date for e-mobility to come. I think I've already mentioned sort of many elements of our policy framework that we think is crucial to optimize EV grid integration, smart charging in private and public, empowered consumers to make informed choices, rewards for EVs in the grid as they provide flexibility, and last but really not least, make the local grids smart charging ready. With that, I'll just leave you with my key messages here. As EVs grow and the demand of EVs grow, smart charging is really essential to reduce system costs. It should be price-based and user-centric in our view, as one but not the only form, but a crucial form of smart charging. And big policy opportunities that we're seeing at the moment are the electricity market reform and the Grid Action Plan that make grids the enabler of beneficial electrification. Right, thank you so much, and I'm looking forward to the discussion.
Julia, thank you for this informative presentation. Many points that you mentioned are very relevant, but I will just use one of them, and that's transparency of the grid, because we all want to see everything digital, ideally very quick and with quick reactions from the DSO side. And maybe Nazir Refa will present his view on this topic, because he actually represents ELAT from the Netherlands, and I know that the Netherlands is a very good example of having lots of services digital and lots of transparency with the connection. He's actually focused on charging infrastructure and the impact of the e-mobility on the grid in his work, and I'm pretty sure that he will provide us a perspective of the DSO on the anticipation of the grid connection demands and on the tools how to make it quicker and more efficient. Nazir, please, floor is yours.
Thank you for the introduction, Patrick. So today I want to talk about the practical research that we actually do at ELAT in regard to grid impact of electric mobility. As other speakers spoke about, so improving the grid planning and grid investments plans. Actually, the DSOs need trustworthy information and really at regional level, the expected power demand of electrification, and that enables them to justify the grid investments and trying to do the grid investments ahead. I will also highlight some of the recent initiatives taken by the Dutch DSOs to provide actually more transparency about the grid congestion issues and how they want to tackle it. Just very brief about ELAT. So we are founded by the Dutch DSOs, but back in 2009, we are mainly focusing on ELAT is a knowledge and innovation center on behalf of the Dutch DSOs, and we are active in the field of smart and sustainable charging in the Netherlands. About 50 FTAs. Shout out to the transport companies and CPOs. So we have a large testing site in Arnhem in the Netherlands. We want to test new type of vehicles and chargers. It's an open lab, so you're welcome to do that. As colleagues spoke about, so the transition to electric mobility is actually taking off. The figure is showing the number of the uptake of passenger electric vehicles in the Netherlands. So at this moment we reach about 5% of electrification. But at the same time, we realize that this transition is not only about the passenger vehicles, right? So it's contains also other modalities. In this figure, we show that's the transition that has and the implications for different type of modalities. And as mentioned, to grasp the impact of this transformation, we are being asked by the DSOs actually to quantify the impact of electrification from grid perspective. What we do is one of the projects that we are working at ELAT is called ELAT Outlook project. So we develop scenarios for different segments within the mobility sector and map actually the expected power demand at a very local level in the coming years. And the output of this research is being used by all the DSOs in the Netherlands to have an idea about the expected power demand and then coming from the mobility sector. I will just dive in how we do that. So in general, our approach contains three aspects. First of all, we develop actually for each modality adoption scenarios. So within three different scenarios, how the uptake of each type of vehicle, battery electric vehicle will happen on national level. And then we go from that step towards creating diffusion models, so a spread of each type of vehicles at very neighborhood level, so at a very local level. And finally, actually, was the most important outcome, and the research that we do for the grid operators is that we create charging profiles, and that one, with that one, we actually quantified the expected power demand at really 15-minute level, and at different type of for different type of chargers and locations. And that's one is actually again the important outcome for a DSO. So usually we do map how the regular charging would look like, and some smart charging solutions. So and of course within that option, the optimization can be different. It can be based on price. It can be based on the expected renewable generation. So yeah, and everything what we do is actually also publicly available for all the stakeholders. So it's not only for the grid operators. Of course, they look more into detail in the outcome of our studies, but also, for example, the municipalities, which are actually more responsible for the rollout of public charges. So they also look into this analysis and try to understand what it means for them. Just when it comes to transparency and sharing information, so we will also publish the outcome of our analysis in a very interactive tool, which shows actually the outcomes at the neighborhood level. We will publish this dashboard in the coming weeks. So when it comes to transparency, right? So probably if you're familiar with the grid situation in the Netherlands, you must have seen this two maps. So one is left one is about the current grid congestion from the supply side, and the right one is about the feed-in. Again, this shows so that current situation and the outcomes and the congestions, of course, meant on the not the individual consumers, but more businesses, and so the higher grid connections levels. And that's actually the start. So at this moment, the DSOs have taken steps ahead. So of course, we know that this is the congestion is at this moment is happening. But for example, one of the main Dutch DSOs, Annexis, is showing at the substation level, they are showing the waiting list. So how many new or additional consumers are waiting for new grid connection, and at the same time they show at each substation level what the expected expansion is in the coming years in terms of megawatts, and the expected feed-in from in the coming years. So again, this information is shown at the substation level, so all the relevant companies can see the information and what it means for them. Again, this one is about at the substation level, and at this moment, new initiatives are taken to go into more detail. So even at the low voltage level, to show what is the current usage, what is the expected usage, so more the dynamic usage of on the grid, and it helps, of course, to understand, to create more understanding and what challenges the grid operators are facing. So that's more in general when it comes to facilitating the charging and grid connections for electrification. What we do at ALAD is one of examples is that we have developed a grid connection calculation tool together with the DSOs and transportation companies. And within this tool, transportation companies can fill in their plans when it comes to electrification of their fleet. So the amount of electric vans that they are aiming to buy, and trucks, etc. What amount of kilometers they expect that they will, what amount of energy demand they will have. And we try to inform them. So what's the what type of grid connection you will need in the coming years. And that's actually also one of the questions that DSOs have towards transportation companies. So to share their electrification plans, and that gives DSOs additional information to tackle and to quantify the expected power demand at the really regional level. So yeah, I keep it short. As I hope that I've given some of the initiatives when it comes to grid transparency, and how the Dutch DSOs are trying to share more information and also get more information to again have more trustworthy information about how to facilitate and do the grid investments ahead for the coming years. Thanks for your attention, and I'm looking forward to the discussion.
Nazir, thank you. That was very informative, and I would immediately have questions to very technical topics. If you can please stop sharing, because we need to see each other. But let's have priority now, because I see there are many questions already coming from the audience.
Yeah.
And I see that Julia is also already answering in the written way, but let's go to the questions that were not answered yet. So from Mikhail Savkin, the question is, how can we turn EVs from a headache for grid operators into valuable assets for the grid, e.g. using them as energy storage assets? What would that take in terms of regulation, technology, and investment? It's a very broad question, and whoever wants to take it, feel free, and feel free to choose which angle you want to answer.
I'm happy to have a go. Unsurprisingly, I think some of the elements I gave in my presentation are part of this answer. So I think we do need stronger requirements on EU, but also on national level from energy regulators that require grid operators to share data on what's happening on the grid. Basically, hosting capacity maps are a key planning tool to open the market for any kind of smart charging services, and to allow aggregators to get in this market, actually. I think what we also need beyond legislation, from EU and national level, I think what we also need is a change in mindset from at DSO level, to become enablers of that transition and to move much faster. What we like to point out is that e-mobility, or basically connecting EVs to the grid, is a tremendous opportunity to actually learn, to get a better insight on what's happening on the grids, to digitalize, to invest, but invest in grids in a way that help them to be used better. So it's also a way of providing investment security to grid operators by adding tomorrow's resources in the smartest way, really. We've pointed out that e-mobility is simply a golden opportunity for DSOs, and we talk to many, and we're actually seeing that the mindset is changing. That they're seeing this learning opportunity. They do want to collaborate much more closely with the transport stakeholders to get a very good idea of the expected demand from electric cars, vans, trucks, whatever will be plugged to the grid tomorrow. And here again, I think it's a combination of a change of mindset and willingness to collaborate, but also the right regulatory incentives, network development plans and network investment plans. do apply to many big DSOs, but I don't see a reason why they shouldn't apply to also smaller DSOs. Just to give you an example, the DSO landscape is very varied. In Europe, we have about 3,000. In some countries, we have basically one, say France. In others, we have many more. In Germany, we have 880. So many of these actually are small, are local DSOs that slip under certain requirements for replying to these obligations. And we actually think that even smaller DSOs can, of course, be asked to design development plans in which they get a good sense of what electric load, what demand will come from the electrified transport sector in the future, and anticipate investments and be ready to integrate these EVs when they're there. That's my 5 cents to parts of the answer.
Julia, my quick comment would be that it's not only on the side of the DSOs to be less conservative, but it's also on the side of the regulators to be more outgoing and try new things and see the e-mobility as the opportunity and not the threat, because we are really the opportunity for the future flexibility services. Anybody else wants to add anything? No?
I think that Julia explained the case very good.
Absolutely. So then let's go to the next question from Lars Ostendorf to Enrique, but whoever feels like he wants to add, feel free. Thanks for your presentation. What is your opinion on bidirectional charging in the sector of heavy-duty vehicles? What impact will this use case have on the grid in your point of view? That's actually a very good question in terms of opportunities, because we always talk about heavy-duty vehicles that need to be charged quickly, but not always, at least in the depots, they are parking overnight. So I'm really looking forward to hearing your answers.
No, yes, I agree. I think that the important thing about the bidirectional charging is related of the use case of each vehicle. What I'm trying to say is that in general, we know that light duty vehicles, they spend a lot of time, stopped in certain places without movement. It's a number bigger than 90-something%. So you have a lot of opportunities to play with the vehicle to grid, etc. No, because there's a lot of opportunities. In the case of trucks, it depends a lot of use cases. In the case, for example, of a distribution truck which have only regional or short trips during the day, for sure it's going to be an opportunity for the logistic operators to have the availability to do vehicle to grid during the night, so during shift periods. You can do a smart charging in a lot of different ways. But there's a lot of trucks that they work 24/7 for several months on a road. In that case, I don't think that it's going to be feasible because it's related with the use case, basically. So my point of view is that it depends. It's something that is going to be possible. For example, if we are talking about buses, municipality buses by night, of course, it's possible. If we are talking about trucks for short periods, short trips or regional trips, for sure, because they are going to charge by night on the depot. But for long haul or 24/7 trucks, it's going to be, for my point of view, very more difficult, because they are going to use all this amount of time for a quick charging and to continue the work that they are going to need. And the second part of the question, I think it was, I don't see it right now, but it was the impact on the grid. I can't recall.
It was actually what impact will, because we dismissed the question already, what impact will this use case have on the grid in your point of view?
Yes, on the grid. I think that if we are talking about energy, it would be for sure significant, taking into account the difference of battery that you are going to have in a truck than if you compare it with a light duty vehicle, for sure. But as I was telling, I think that this is something that is going to be more feasible with light duty and in certain use cases. So what I think is that for the grid, it's not going to be something different or completely, game changer. It's going to be a support that when the maturity of the market increase is going to be probably bigger and bigger, but not something, game changer from my point of view.
Well, it will definitely be a big impact on the highways in terms of the megawatt charging. This is at one day in place, I guess. So there will be a high demand for big capacity if we actually want to charge fast. But maybe let's go to the other question, which again goes towards you, Enrique, because Gerd de Mil actually asks, in your opinion, the investments in the grid can be done by 2030 and 2050 for full electrification of transportation. My question is that also the case if you include also all other grid investments that need to be done to electrify other sectors in order that they also can reach their net zero targets? Second question. Okay, let's answer the first question.
No, well, it is. I think it's a good question, and it has a connotation of doubt. I think that the person who is asking thinks probably that it's going to be really challenging. I completely agree. But I think that there is a difference between something challenging and something impossible. With the correct planning and with the correct regulatory framework, it's going to be feasible for sure. The issue here is that the question is very, very global, very, very broad, because they are talking about more than transport. We have numbers about what is going to imply in the different countries in which we have presence. And in all of them, it's something feasible with, we can share the numbers right now because I didn't expect this kind of global questions. But what I can explain is that it's going to be feasible. And what we need is planning and the correct regulatory framework to do that. Because not everybody is going to do all the electrification at the same time and in the same way. So we can, split efforts. And what I was explaining before, we managed to increase 61% in 10 years of demand without any, issue, operating issue in the country. So it's something that is completely possible and feasible from my point of view.
I think we have to realize that all the investments have been invested very incrementally over the last 40, 50 years. And we have to take into account that this electrification and so also upgrades of the grid will really take tens of years, maybe even longer than 2050. Exactly. And it's ongoing process. And maybe with these doubts, which you actually mentioned already, I would expand the question by the second part. What is the necessary investment in the grid compared with the necessary investment into the grid for other sectors to reach their goals? Can you share these figures? I assume that Gerd de Mil actually asked about electrification of the heat and industry.
Yes, I cannot share the numbers right now because I don't have it with me, being honest. But what I would like to express here is that transport is going to be probably more significant in the increase of the demand than other sectors, because in other sectors the energy efficiency is something that we need to take into account. There's some some interesting cross effects between technologies in which you are going to increase the electrification, but probably you are not going to increase the demand that much because of the better efficiency of the new technology. So, it's a very difficult question to answer in the extent that the person is asking for. But what I would like to explain is that from a point of view, transport is going to be more significant from the electricity sector than probably other, talking about the increase of the demand, than other sectors in which I think that we have very good prospects for electrification. But saying that, I don't have the numbers with me to compare investment, because I think that the question is related with investment on the grid. So I don't have it, I think that everybody knows that it's going to be massive in this period of 40 years, about 30 years. But I don't have the numbers with me, so apologize for that.
Interesting,
Could
Enrique. Absolutely.
Could I make a small addition? It's about the planning and basically what type of use we're planning for. So yes, indeed, I think it's without doubt that grid upgrades will be needed for electric truck charging, for example, connecting highway megawatt charging stations. But what we would like to stress on the planning level is that the planning exercise should always go along with optimization scenarios. So basically, you can plan for a maximum amount of capacity needed because of all trucks needing to charge at the same time. Which can happen, especially as the market grows. But you can also plan for more likely scenarios that the charging will happen with a certain factor of parallel, that it can be shifted in the limited windows of flexibility that these trucks have. I agree that we need to separate highway charging, which is probably the most difficult, let's say, case, because there's little optimization possible, but there is, from depot charging, where you have plenty of flexibility available due to the fact that the delivery trucks will charge overnight. So what we encourage planners to do is to basically run optimized scenarios to see how many millions of investments you could save by planning for the 99% of times that not all charging points will be used to the maximum capacity, and then of course use all the let's say on-site mechanisms of load management to avoid that there's the one incident where you would really overload or create a local overload. So with this in mind, just by adding a planning perspective in this regard, you already address, let's say, many of those fears. We have talked to owners of bus depots that were in different cities in Europe, and that were surprised to see that they could make several millions of euros of savings by planning their charging in an optimized way. Buses stay overnight. Same goes for electric depot trucks at the depot. We ran a study I think 3 years ago with ICCT, where we looked into a simple optimized charging schedule of electric trucks at the depot in Germany, and that's based on data by a real operator, that is big logistics operator that is electrifying, and they found that they could save 10% of their total energy cost with an optimized charging schedule of 10 electric trucks. So this is interesting for fleet operators, and we always encourage them to optimize their consumption right away.
Julia, this is actually a good point, and I would really, at the technical level, would really be very curious. What is the percentage that we can actually save in one high capacity hub, and let's not talk about only heavy duty vehicles. If we talk about 4 and more ultra fast charging points, and with all this optimization with the load management in the hub, what is the percentage of savings from the total reserved capacity as the maximum nominal power, and not to actually invest too much into not only fixed costs, so investment, but also running costs, this variable every month, which is paid for the guaranteed capacity connection. But maybe this is a good question to Nazir, and I would expand this question by the one from Aaron Fishbone, who is asking to elaborate more. How do you do the calculations and projections that you talk about? What data sets do you use? What assumptions do you make? Curious about the really tangible way your projects and calculations are made. I mean, this is actually, we have I see 8 minutes to finish. So this is actually questions for entire webinar.
Thank you. I just had, to be honest, I had a slide about it, but I hid it. Anyway, I just want to mention some, add something to what Julia said about the smart way of making use of the grid. So one of the initiatives that is actually implemented right now in the Netherlands, it's mainly implemented on the public charges, is a national program where we from the DSO side contribute to, and actually together with the municipalities. When it comes to smart usage of the grid and the capacity of the charges, it's not always that you go down, right? So that you lower the power. What is done in this initiative is that say, okay, where we say during the peak hours, you actually provide a certain amount of power, you allocate certain amount of power to each charger which is being used, is in use, so about 4 kilowatts. But during off-peak power, off-peak times, there's plenty of room on the grid, right? So that enables the charge CPOs to actually cluster the power allocated power to the chargers and actually provide more power to the EVs. So then, in an ideal situation, the EVs are charged faster, and then you have less demand on the when this mechanism works on the long term. So again, that's one example that's happening right now in the Netherlands. When it comes to the modeling, so we make use a lot of public information coming from our Central Bureau of Statistics at the regional level. So it's quite complicated because we talk about bringing mobility and energy transition together, and with this research we are actually trying to do that. Is that on one hand, you need to understand what's going on in the mobility world. So what amount of cars, how do people use their cars? We get a lot of information when it comes to usage of vehicles and potential and future usage of vehicles from a lot of mobility studies that are happening in the Netherlands. At the same time, we have access to a lot of charging information. So we try to bring those two insights together. What we see at this moment with the happening at the chargers, and we try to bring those two information sets together and actually try to understand what will happen in the future. So we know for sure that certain aspects and will change. That, for example, you get more EVs on the road with relatively bigger battery capacity. At this moment, a lot of people who are driving electric vehicles are doing that for business purposes. So they drive on general more kilometers. So in the future, you will have on relatively per amount of vehicle less kilometers. So there's already relevant aspects to take into account to come up with reliable information and expected power demand. Just in a short note. Yeah.
Thank you. I see that Julia is actually busy writing answers. So I encourage everybody to look also to answered questions, because I see that Julia was answering the question on the cybersecurity and European Data Act, which is very important in this respect. And I would definitely have questions on this. But before that, Luca de Bruichere is asking, how will we ensure EV cooperate with other large loads in buildings, such as heat pumps, to make sure they align their consumption to the extent possible and link it to the production of on-site renewable energy? Julia, you're typing, or you want to answer right now?
Thank you. I mean, I was actually just typing an answer to Luca. This is a really crucial question, and thank you, Luca, for bringing it up. I mean, there's different, I think this type of optimization is what we ideally want to see. Households have the biggest future potential of flexibility in Europe, and that's often forgotten as a source. I think as a principal answer, what we'd like to see is optimization services or services for demand response with everything you have, in terms of flexible resources in your household, to develop in a market type way, so users can see what's on offer and choose the service which is best for them and which works for them, because they're very different use cases. And why do I insist on that? Because we want smart consumption to be user-centric. We want it to be transparent, and we want a market of offers to be developed, so optimization can develop with the resources, with the grid, and with the availability of renewables. We think this is a preferable approach than actually controlled approaches, for example, from grid operators or service providers. So and this is where it links back to Nazir's example. I think this is really interesting, that what the DSOs in the Netherlands are trying to do, and the example you gave from basically load shifting at CPO point certainly works from a grid point of view, because you work with existing capacities. Our only remark would be that the user should be in the center and should be able to choose what's best for them. So any kind of these services to develop, we would prefer that from a regulatory point of view. And I'm going to put a new report by my colleagues in the chat as well, who have looked into household demand-side flexibility and how it can be unlocked for actually all types of use cases.
Julia, you will be releasing a new report, an update of the report which you mentioned in 1 or 2 weeks, correct?
Different things in the pipeline. So we're working with my colleague Jaap on an update of the smart charging tariffs and these tariffs and services, let's say, maps that I showed you. Expect that for later this year. What's coming in a good week from now is an analysis of cost of megawatt charging, basically for the highway truck charging case, which will probably interest Enrique a lot. Where we've looked into, we basically put the hat on of a CPO, and we looked into costs of providing megawatt charging services for electric trucks. And why do I mention that here? Because these costs are actually also determined from the grid and in what state it is, what it costs to use it, how much capacity is there, how the grid tariffs are structured. And what we're seeing, and I'm giving you a sneak preview now, is that these grid costs are very different depending on where the megawatt chargers are located. And this is a case for European coordination, because what we do not want to happen is that megawatt charging exacerbates existing imbalances on the grid. We want megawatt charging to use the grid in the best way and charging to be balanced. And from the results that you're going to see in a couple of days, we will need some coordination between member states to make sure that trucks charge with the right capacity at the right time in the right area or country. Stay tuned for more.
I see that heavy-duty vehicles and electrification of this segment is actually becoming a big issue, and there are lots of talks, not only during our webinar here. Thank you for this teaser, Julia. And as you are teasing, I'll be doing some teasing as well, because this webinar is not the last one, but AVERE will actually organize 4 more episodes or parts, where we will deep dive into more technical aspects and the topics such as cybersecurity and different aspects of smart charging, which can actually expand into bidirectional charging, and the feasibility and opportunities for these topics will be also reviewed in the next webinars in this series. However, unfortunately, every debate has the only enemy, and that's time. And we are actually at the end of our today's webinar. So I would like to thank to our panelists. Firstly, Enrique Merono from Iberdrola, to Julia Hildemeyer from Regulatory Assistance Project, and to Nazir Refa from ELAT Netherlands. Thank you to all of you. Your presentations and contributions were very informative, and I'm looking forward to talking to you next time. Have a pleasant day, everybody.
Thank you very much.
Thank you so much.